Meaning of derivative. Now let's go over what we already know. We know how to find an average rate of change. We did that in class. We used to call this a long time ago, back in Algebra 1, we used to call this slope. And we can estimate the instantaneous rate of change by using smaller and smaller increments. And when I say smaller and smaller increments, what does that mean? Well, what it means is we are going to choose x values that are closer and closer together. Now, that also means that the y values are closer and closer together. The instantaneous rate of change of f of x, a function, at x equals c, some x value, is the limit of the average rate of change, the slope, over that interval from the c, which is an x value, to x, which is an x value, as x approaches c, which means as x is trying its best to become c. So, meaning of derivative. The derivative of function f of x at x equals c, some x value, is the instantaneous rate of change of the function with respect to x at x is equal to c. It's found numerically by doing what we just talked about, taking the limit of the average rate. Okay, so numerically, we are going to take a limit of the average rates and this average rate is over the interval from c to x as far as the x values go, and this limit is as x gets closer and closer to c. So for example, we were asked in class to talk about the instantaneous rate of change of our function d at time is equal to 1. So what we looked at the average rate or the slope between 1 and 1.1, between 1 and 1.01, between 1 and 1.001, between 1 and 1.000001, etc. So we're trying to get 1 and that second number we're using to be as close to being the same number as possible. Graphically, what does that mean? What that means graphically is we're actually finding a slope, literally a slope, of the line tangent. What does that mean? So we're finding the slope of the line tangent. We can also call that the tangent line. And we want to do that at x is equal to c. So in the case of what we did today, we wanted to know at time was equal to 1, so our c value would be 1. So when x is 1, we would literally take a ruler, we would line it up to be tangent. Tangent, though, we learned something about tangent in a variety of classes. This tangent's not the trig tangent. This tangent is the geometry tangent. We talked about circles. And a tangent line from geometry, when we had a circle and we had a tangent line, it touched the circle exactly one time. It was right there on the edge. And that's what our tangent line does to our function. So it touches the function, or the graph of the function, exactly one time. So a tangent line from geometry with circles is the same as the tangent line in calculus class. Now we need to talk about what with respect to x, what that means. So that indicates that you are going to find how fast y is changing as x changes, because it's just like slope. So it's exactly like slope. So when we talk about with respect to x, that's the bottom of my slope. So the bottom of my slope is as x changes. And again, the top of my slope is y. So with respect to x means you're finding how fast y is changing as x changes. In terms of slope, that means the change in blank is the top fraction, that would be y, and the change in blank is on the bottom fraction, and that would be x. Thank you for enjoying this note lesson.